Right, critical regions again. So these are regions for which the alternative hypothesis is accepted. We don't have to talk about a critical value because we're in a continuous distribution. The probability of being at a particular value is 0, which we've spoken about a bit. So just going with regions on this one. Right, example. Sorry, these examples are a bit random, but anyway. So a machine is designed to make paper clips with a mean mass of 4 grams and standard deviation of 0.08 grams. A quality control officer, they're back, weighs a random sample of 25 paper clips and carries out a hypothesis test at the 5% significance level to determine whether there is an increase in the mean mass. So we're looking for an increase, and we want to find the critical region for the test. So we're dealing with the sample size. Normally when you're finding a critical region, you still have to state your hypotheses. And so we're dealing with a sample mean, which will be normally distributed. The mean is 4, and the variance will be 0.08 squared over 25. And then the null hypothesis is that the population mean is 4, and the alternative is the alternative that there might be an increase, which will make the mean bigger than 4, and then make sure you define your mean. And so for this one, if I draw a quick sketch, so we have mean at 4. We're looking to see whether there's an increase. So we're looking over this way, if there's going to be an increase in the mean. And the critical region is going to be this region here. It's a 5% significance level. So we're looking at that being 5% or having an area of 0.05. And so you need to use the inverse normal function that we were doing a lesson or two ago. So I need to consider Z, which is normally distributed, mean of 0, standard deviation of 1. And we want, remember your calculator will only do less than on the inverse normal. So we're actually looking for the probability of Z less than Z to equal 0.95. If we were looking to see whether there'd been a decrease in the mean mass, you do exactly the same thing. That would be less than, and you'd be looking for that to be 5%, so you'd be doing probability Z less than Z equals 0.05 instead. Okay, so calculator. So very much on menu 7 still. And then we're doing inverse normal. The area to the left is 0.95. It defaults to standard deviation 1, mean of 0. And you get 1.6449 or 4485. Remember, you can store that to X if you want to, and then come back to it later. And so Z is 1.64485, sorry, smudging again. Right, and then we need to map off of the standard normal curve. So Z is equal to X minus the mean over standard deviation. So 1.64485 is equal to the mean of the X, which we don't know, minus the mean, which is 4. Remember, we're in this distribution here of the sample means, not the population distribution. And so I need to divide by 0.08 over 5. And we need to find out what this sample mean is going to be. That gives you the area to the left of it as being 0.95. So, calculator, menu 1. So personally, I would just whack that in really. So 0.08 divided by 5 times x plus 4. So 4.0263. You'll know if you've gone wrong because you're going to get something stupid coming up. So we're expecting something around 4. And then that means that this value here is 4.0263. And so anything greater than or equal to 4.0263 will be in the critical region. And the probability of having a mean of that size or higher is so low that you go, hang on, I don't think this is the correct distribution. I think the mean is a bit bigger than 4. So critical region if you don't understand hypothesis testing, give me a shout. I'll do my best to explain it to you. So greater than or equal to 4.0263. Once you've got it, you know, they're quite right really. So that's that bit. And then last little bit. So the quality control officer will probably appear again at some point in another question. Takes the mean of the samples and gets 4.048 grams, and we can decide what conclusion can be made. So 4.048 is bigger than 4.0263. And so it's in the critical region. So therefore you accept H1, the alternative, because you're saying that's too unlikely to have happened by chance. And then a conclusion words. Remember, with hypothesis testing, you don't actually say it's right or wrong, you're just collecting evidence. So there is sufficient evidence that I know you're going to get really lazy about writing these conclusions, but if you don't do it on a test or an exam, you will lose a mark, guaranteed. There is sufficient evidence that the mean weight of paper clips has increased. And I hope that's enough for you to have a go at one or two.